Okay, welcome everybody to my talk about debugging your GPU workflow. My name is Spencer Fricke. I also work at LunarG. So a bit about me. I've been part of Vulkan for quite a bit now. Been part of the working group for a few years. It's been 2 years now since I've been at LunarG. The last year has been very focused on the world of GPU tooling because we know the world is only pushing towards the GPU ecosystem. Also, if you find me out there, if I'm talking too much, you can walk away. I'm okay. I'll find someone else. I like to talk. So today we're gonna talk about a bunch of things to help make your life better, because let's be honest, even though you're a bunch of graphics debuggers, GPU debuggers, developers, you probably much rather debug your CPU than your GPU, which is totally fair. I want to just show you guys some cool tools and even some of the API that you can use to make your GPU debugging workflow a little bit nicer, so it's not this dark AI generated vibe that can't even spell debugging correctly, but no, back that point. So promise me the last generated image. So when you're debugging your GPU, you have to think of it like a toolbox. There's currently no one fits all tool. You're gonna have, depending on what you're doing, you're gonna have to pick out the right tool for the right job to kind of debug your GPU. And so we're gonna talk about some of these tools. So the first tool is kind of a smaller one. It's robustness. Who's here has ever used robustness? Oh, a few brave souls. Okay, so robustness has a lot of things to it. It's kind of famously known for being like the one feature in Vulkan that if you enable it, you might have some performance reductions because it's hardware level out of bounds checking. That's what you can think of it. And the web GPU world likes using this or needs to use this because they can't let malicious apps poke at memory. So you have to make sure things are checked. So, and it's not the best, most fun thing to read in the spec. So there's a guide article you can read about it. But let's take a little fun example here. I have a storage buffer, and this storage buffer has a runtime array. So you don't know how big this is, and you're indexing into this buffer. So clearly, you might not have bound enough memory, and you might be out of bounds. So this potentially is an out of bounds access. Well, and you might have a crash or an error or a bug. If you go, and this is Vulkan 1.0, if you turn on your robust buffer access feature, it will ignore the writes, load 0. Robustness almost always loads 0. There's a few cases it loads 1, but you can think of it just as like it zeroes out memory. And if you turn this on and your crash goes away, well, cool, you can fix your bug and get lunch early or something, but it's a quick, simple check. That's how I look at it. It's a quick little tool you can add, no problem. But there's more robustness. And it's right. So in this case, we have descriptor indexing. So you have 4 buffers in your array here, and you're indexing to the third one. But you're using partially bound indexing. So maybe you've never bound this buffer. So now you're just accessing an undefined value. This hangs my personal device, so I know it probably might hang yours. And so what null descriptor does is it's actually part of the robust 2 feature set, and this lets you set all your descriptor indexing descriptors to null to start with. And with that, now all these accesses will be valid, like they're valid. You're not going to crash. You'll again ignore your writes or read 0. So another quick little tool you can quick test, flip on and off to see if it suddenly surprisingly fixes your GPU problem. But robustness has limitations, and this is where it gets really kind of the nuance of it. If you go out of bounds in your descriptor of arrays, there's no robustness that's going to save you. Okay, this is now just you're gonna just have a bad time, and there's nothing to save you there. So you're gonna need another tool. And so we're gonna talk about GPU AV. This stands for GPU Assisted Validation. It's an optional opt-in setting for the validation layers that you guys can use. Maybe some of you've used it. It's like those last examples, we don't know the value until you actually submit the work on the GPU. So we instrument the shader, read the values out, and then report the error afterwards. So this is why we have to defer that work. This is not a new thing. We've actually had this for, I'm thinking, like almost 6 years or something. But it's been kind of just in the backworks. It's been on the backlog. Everybody has that backlog of things we'll finally get to do. Well, last year was kind of the year we decided to really step up and get GPU AV to work. So it's getting reworked a lot. So shout out to people like Sergey, who's been my favorite SDK Every time there's new SDK, he's testing it and checking it. So thank you anybody who's testing it for us. But just some FYI there. So to use it, very simply, just get vkconfig. This is vkconfig 2, but vkconfig 3 is the same thing. You get a preset, you turn it on, done. Cool. You can also use the layer setting extension, which just lets you use it at create instance time. You can turn on any setting for any layer you want. That's kind of the whole idea of that extension. There's also the environment variable. The warning with this for the last two ways to do it is the vkconfig preset turns off core validation. So you're only doing GPUAV, because if you're going to do GPUAV and core validation, it might get really slow, really fast. So we highly suggest you just use one or the other. Lastly, we have this old vkext validation feature. This is deprecated in the sense of we're never touching this again. If you use it, if you have it working right now, it's always going to work. So please feel free to keep using it. But if you're just about to add support, just ignore this and just use one of the first three settings. Okay, thank you. So going back to this now, GPUAV, one of the first checks we have in here is descriptor index checks. So this will do things like that first example, where if you're out of bounds, it's going to notice it and it's going to do its best to make sure you don't. We do fun, cool little things to make sure you don't actually do the operation, so you don't just crash on the spot. And we also detect like your uninitialized and destroyed descriptors as well. But then if you might, for example, have an array of 3D images and you index into one just to find out that it's been backed by a 2D image. So we don't know which image it is until you access it. And so that's, again, why we have to defer that work offline afterwards to post submit time. So that all gets done with the descriptor indexing checks. Next is buffer device address, which I admit we have too many names for. You might know as buffer references, physical storage buffers, or just I have pointers in my shaders. So here's a little code. Basically, you have a pointer here, and the pointers are just defined as UN64. So you have a UN64 value, and you dereference it. And I say dereference because this is all about lies. The details are the devil's in the details. So you dereference it. Well, just the biggest thing we can tell you is, one, if it's not aligned correctly, that's going to be a problem. So we'll let you know that. But also, if you haven't used this, you create a buffer, you get that buffer address. So you only have so many buffers that address can be within. So if you're not in any of those ranges, you're clearly just have a bad pointer. So we can tell you that and report you there if you have a rogue pointer somewhere. So it's your best bet if you're using pointers to at least turn that setting on. So sometimes the contents of your buffers go bad. So let's say you have a simple quad right here, and you have your little index buffer, 6 values in there, very simple, but you're very clever. You're a clever graphics developer, and you decide to dynamically update your index buffer mid-command buffer because, you got this cool new idea. And in that process, you've accidentally added a negative value in your index buffer. Well, this is an old issue we had because someone did this and they had had a GPU crash and they took them forever to figure it out. So now we have all these checks to check the contents of your buffers as well. And so there's various forms of this. There's like the indirect parameters of like draw indirect. If you do copy into a depth stencil, if you don't have certain extensions, it has to be between 0 and 1, stuff like that. We check the contents of your buffer with the buffer content part of GPUAV. So GPUAV still growing. We're excited to make it faster because we know it's not the fastest. We know the error messages can be better. And then we also, again, the new extensions coming out, like scripter buffers, device generated commands, ray tracing, mesh shading. We're slowly going to be hopefully add them in this year. That's our goal. But honestly, what I want to hear from you guys, today, tomorrow, is I want to hear your war stories, because we know that there's definitely people here who spent a week on what they thought was the hardest bug just to find a one-line change in their code, and they wish a tool would have been there to find it. So let me know what, some things are, we can only do so much, but let me know those things that you guys have found that you wish there was a tool for, whether it's GPUAV or anything else. Like Karen said, your feedback is important. So GPUAV and most other tools have a few limitations. So one of the main limitations is doesn't integrate with your, Clang GCC compiler. We can't read your source code. It's a layer. And also we can't read your mind because at some point I'm just getting random API calls in and I don't really know what you're trying to do. And then some of you guys do some really clever stuff. So if you guys aren't aware, there's this extension called debug utils. It's been there almost since day one. It's basically a way to put a string to your handle. And it is, if you're not using it, you got to go home and tonight add it to your code right away. It will print out better, not just validation error messages, but I'm assuming most other tools are going to be consuming it as well. And to show you how simple it is, I'm putting this all on a presentation slide. So you have your clever engine create buffer call, and all you do is you add a little string at the end. What is this buffer? So inside your engine code, it's very simple. You create your buffer just like normal. And all you have to do afterwards is take that handle with a name you want to give that handle, and then you call the vk set debug utils object name ext, and now you suddenly have an error message that includes your which buffer it is or pipeline or whatever. So that's great. That's, you know, that's 101 stuff. But some of you guys have a lot of draws, okay? And do you really want me to tell you after a GPUAV error message, do you really want me to tell you your 53rd draw call is the problem? Is that really are you guys really gonna go in there and start counting? Probably not. So there's another part of debug utils that lets you label your command buffers. So you start a command buffer and then you give it a label. In this case, region 0, and in this case, region 1. And this is a stack-based system. So at the bottom, you can see you can unstack them. So then somewhere in the middle here, in your large command buffer, you do something bad, and we report the error message. We can now tell you which part of your command buffer it was in. So especially with things like the GPU workload, where somewhere in this large command buffer, you had an issue, you need to put some regions labels, some region labels, some debug labels in there if you want any tool to give you a better error message out. So this is the stuff that you guys can do to make your life better. So quick question. Who here likes debugging their CPU stack traces with a release build? You know, just looking at that, just raw 64-bit pointers. Yeah, I didn't think so. So why are we doing this on the GPU? This is crazy, right? So, oh man, this formatting here. Non-semantic shader debug info. So it's a way to, this is a classic example people always ask, like, hey, I have my spear V. I want to map it back out to my source code. And this is kind of the answer for that. RenderDoc makes extensive use of this, and this is how it lets you step through your shader. And then recently, the validation layer has also added support. And this is like night and day difference. Do you want me to tell you the 41st instruction in your spear V was the problem, or do you want me to just point to the source code? Like this is like the difference of like proper debugging and just, you know, bang your head against the wall. So it takes 3 things to get this to work. First, you have to make sure as an app, you support KHR, shader non-semantic info. This was added. It's basically, we need a way to guarantee that the compilers will just ignore this instruction. So you might get away without it, but it's probably very widely supported now. You need to make sure your shading language produces the debug info, which we'll get to in a bit. And you have to make sure your tools actually consume it. So all of the main shading language things already have this. They all have a flag. DXC is a little long, but the rest of them are very, you know, it's there nonetheless. And think of this as release with debug info, because while your spear V will get very large, it's going to be optimized out in the first pass. So in theory, this should be the same speed running it. It's just going to be a very fat spear V binary. So definitely have a debug build flow that you just turn on these, you know, settings to build your shaders. That way, when you want to debug something, you can just do it, and it doesn't cost anything but some size in your spear V. And then I want to thank Boulder, you know, the RenderDoc Boulder, because RenderDoc's awesome, but like he's the one who spearheaded this whole thing for Vulkan. And I feel bad because us as an ecosystem have not really embraced it. I feel embarrassed that the validation layers did not have better support. So recently I've been trying to add it for just normal CPU validation. And so hopefully this year we get it going. But also if you have a tool out there that consumes spear V, I will admit the non-semantic shader debug info is not the most fun extension to grasp. So there's a little spear V guide article I wrote to help that. So I want every tool to support this that can. So with that, okay, next tool, debug printf. So printf, you've probably used it in your normal CPU workflow. Same thing, but on your GPU. You can print out a value in your shader, just as you would think it would be. Very nice little trick for ray tracing. If you want to know if you're in the hit or miss shader, you want to know actually what's happening, it's a quick, dirty way to do it. But if you have millions of invocations running, you're gonna get millions of printf messages. So please try like wrap it with something like, your built-in GL vertex index or, your work group size index, just so you don't spam yourself. But debug printf is a very simple idea. All it does is you take a value, you put in a buffer, and you read it out later. And then you just do sprintf on it. The secret, I'll tell you right now, both render doc and validation layers just do that. We just call sprintf on it afterwards. But we standardized it with the through the non-semantic info. So any tool can also support it. So if you have a tool that wants to support debug printf, you can also add it. So you need two things to get debug printf to work. It is so simple. I think a lot of people think it's gonna be like hard, like Vulkan. It's not fun. It's gonna be hard to set up. It is two simple things. You need to add to your shader and have a tool to consume it. So to add it to your shader, it is pretty simple. GLSL takes an extra line, but if you're in HLSL slang, just add printf right now. Just go to your code, add printf right now. It will automatically generate it for you. That's all you have to do. Okay, it's that simple. Yes, that simple. Okay, so once you do this, you need someone to consume this value, right? So what I'll tell you right now is just go to the VK config and turn on the debug printf settings. This will just replace your normal validation error messages spot with printf. Another thing that's nice is it turns off all of core validation for you, so it's only printf. But we found that many people wanted a faster way to get going, and for various reasons might not have VK config. So with the last SDK, we've actually added a new preset. It's just printf only preset. If you turn that on, optionally you can turn on the std out if you want. You just turn that on with the printf in your shader, and you get the printf messages. There's nothing more to it. So if that doesn't do it for you, please report a bug because that's something's wrong. Because it should be that easy to printf your GPU code. So yeah, and then if you want to look at later how it all works, this is also my shameless plug that for all your compiler, explorer, cult followers, that you can now do all this stuff online. So final note, as Karen just mentioned, for various reasons, we weren't able to do it simultaneously with GPU AV. That's now gone. So that's something I want to point out. So yeah, okay, let's go on to another thing. Let's say you're getting an error device loss. What do? I mean, you could just, I would say you probably a lot of different answers for some of you guys, but I found that a lot of people don't realize this. We have a thing out here called ext device fault. It's been getting more and more support, and it's a very simple idea. You call your qsubmit, and after you call qsubmit, you found, oh, I got a device loss. You do a very generic Vulkan query into, you do the double query thing, and you get back, hopefully, a bunch of useful information from the GPU driver itself, who's probably going to know more about why you crashed or got the error loss than anybody else. So what's better, and it's a little kind of spoiler to Jeremy's talk, what's better than using that yourself? Having Jeremy do it for you. So the next talk, Jeremy's going to talk a lot more about how a crash diagnostic layer basically just does this for you in a nice formatted way. So the toolbox is large. I had to be nice to Jeremy and give him time to talk. So, no, you guys probably already know about render doc. I'm excited to see things like GPU reshape out there from the AMD Open people. That's awesome. More tools like that are needed. All your vendor tools are great when you can use them, and same thing with your platform tools when you can use them. Awesome. So there's a saying, if you guys aren't aware, that it takes a village to raise a child. What it also takes a village to raise good tooling, okay? So how this works is you guys, first as app developers, complain, and you complain, in the various forms you want, Vulkan spec, the new Discord pain point. Tell people what kind of issues you're having. Because again, there's a lot, as like Tobias mentioned, we just sometimes don't see it. And then what you do is you get someone like Ralph Potter who wants to, really get everybody to support. And I do want to thank Ralph because he's the one who did get device fault to get going. So you get all the vendors to actually support it, which can be, its own struggle in its own way. So once you get everybody supporting it, then you just need tools. Like as I've showed before, you need the tools that you're using to do it. I mean, you can do it yourself, but it'd be nice if the tools just did it for you. And then once you get the tools, you got to start actually using the tools. And you complain about what the tool's missing, and it becomes a cycle. And this is how, as an ecosystem, over the years, we can build better tools, is this kind of cycle. Because there are things that we do need hardware level information out to, such as device fault and more that Jeremy will talk about. So it is truly like a full cycle here. So yeah, final reminder, your feedback is incredibly important. I'm always amazed talking to some of you guys, what you guys actually do with Vulkan. So it is enlightening, and yeah, we hear everything you say and take the survey. Thank you.
Awesome stuff. Just to echo the point, I guess we develop a lot of tools ourselves. Label things, please, and think about how those labels get presented. My favorite debug label stack I found so far in real games is 770 characters long. So how you're supposed to present that to a user, I have no idea. So yeah, labels are important, especially if you're trying to target game developers who are above the API. By the time things get down to a Vulkan handle, they've got no idea what you're talking about. So labels are really important. Thank you.
Is it possible to surface this information in some sort of a GFXR trace so that a profiler could pick it
Which
up?
information?
Debug information that we are.
So the trace is just capturing what you have. So the trace, in theory, should be able to capture your debug label, and it should be able to pre-play it back. So I mean, anything yeah, I mean, if it's in the trace, it should be able to be. It's there. I mean, as long as it's in the trace, the GFX people can get it out somehow. So definitely, as long as it's in the trace.
Got it. Thank you.
I'm just giving more work to the GFX team right now.
Any last questions before we? Okay, another round of applause for our speaker.